In this illustration, we'll analyze the air pressure in a rotating tube. We are given that a horizontal cylinder closed from one end is rotated at constant angular speed omega about vertical axis passing through the open end of cylinder. Here we are given that the outside air pressure is equals to P0 and air temperature is T, and we can take molar mass of air to be m. We are required to find the air pressure as a function of distance r from the rotation axis. Now in the solution, we can first draw the figure. We are given with a horizontal cylindrical tube which is closed from one end and it is considered to be open from other end, and the tube is considered to be rotating at angular speed omega. In this situation, the frame of tube, all gas particles will experience centrifugal acceleration in outward direction, due to which pressure increases along with the depth. So here at a distance x from the axis of rotation, we can consider an elemental layer of width dx. If we consider pressure at left of this element is P, then on the right of it can be written as P plus dP. It will increase. So we can write increase in pressure across the elemental section of air is, this can be written as dP, which is equals to dx multiplied by rho multiplied by, instead of g we can take as omega square x, which is the effective acceleration acting at this point, which is omega square x in the frame of tube. So here we can also write from gas law as P is equals to rho RT by M. This first equation, from equation 1 we can write dP is equals to, this rho we can write as Pm by RT multiplied by omega square x dx. Here P can be taken on other side, so this dP by P is m omega square by RT multiplied by x dx. If we integrate this relation at x equals to 0, pressure is atmospheric pressure, which is P0, and at a distance, a general distance r from the rotation axis, the pressure is P, then it can be given as ln of P by P0 is equals to, here we can write m omega square r square by 2RT. And from here we can write, if we take anti-log on the two sides, this P by P0 is equals to e to power m omega square r square by 2RT. So we are getting the gas pressure as a function of r. We can also write this P as r is equals to P0 e to power m omega square r square by 2RT. This is the final result of this problem.